Alright, so today you're going to be reviewing for what we've learned already in Unit 3 on our polynomials and their graphs and on our composition of functions. So I just wanted to give y'all a quick review video because you're about to do a review sheet and this will help you with that. So the first thing that we learned in this unit was our rational zeros theorem. Okay, if you remember, this theorem tells us not how many, but what the possible rational zeros are of a function. So where Descartes' rule tells us the type of zeros that we're going to have, and we can use synthetic division in our calculators to find out exactly what zeros there are. This is kind of the way to do it without a calculator. So if you remember, the rational zeros theorem was P over Q, where P are the factors of our last term, and Q are the factors of our first term. So if I was to give you a super simple equation like 2x squared plus 6, I would take all the factors of my last term and I would put them on top. So the factors of 6 are 1, 2, 3, and 6. And we put positive or negative because both the positive numbers and the negative numbers are factors of that. And on the bottom, we put the factors of our first term, 2. So 2 only has 1 and 2 as its factors. Now remember, I'll allow you to leave it like this, but this means that we have the factors 1 over 1, negative 1 over 1, 2 over 1, negative 2 over 1, and so on and so forth. We have to put each number in the numerator over each number in the denominator. So then the question is, well, not all of these are rational zeros because this function only has 2 zeros because of its degree. So what if I want to test to make sure which one's a zero? I'm going to pick one of my zeros and I'm going to use synthetic division to test it. So you're going to be asked to do this on your review sheet. I'm just going to ask you to pick one zero and to test it. So if I wanted to test 1 over 1, I'm going to put my 1 on the outside. And remember, I put each coefficient on the top. So 2, I don't have an x in the middle, so I have to put a placeholder. And 6. And then I would complete synthetic division. Because my remainder was not 0, this is not a factor. Okay? My remainder has to be 0 in order for this to be a factor. So if I ask you to do this, you'll do synthetic division with one of your possible zeros, and you'll tell me whether it's a factor or not, based on what the remainder is. So that's our rational zeros theorem. Alright, the next thing we moved into were our operations on functions. So if you remember, that's where we learned all of these operation notations. And all these are fancy ways of saying take those functions and add them, subtract them, multiply them, divide them, and then we had our fog. Okay? That's our composition where I take G and plug it into F. And that's the one I'm going to show you. So if I have that f of x equals 2x and g of x equals 3x plus 4, and I get fog, I'm going to take my second function, so my g, and I'm going to plug it in for the x of my first function. So everywhere that I would see an x in my first function, I'm plugging in my g function. So for that x, I'm going to plug in my g function. And then simplify. So I say 2 times 3x is 6x, and 2 times 4 is 8. So this would be my final answer. Always simplify as far as you can. Now we also did composition with a set of coordinates. Okay? And that is where we made our 3 boxes. All right? So if I give you a set of coordinates, like 3, 2, 2, 4, and that's f of x, and I tell you that g of x is 6, 3, 4, 2, I'm going to take whatever my second function is, my g, and I'm going to put the domain in this first box. So my domain of g is 6 and 4. Then I'm going to put the range of g in the second box. So the range is 3 and 2. Then I'm going to take those and make those my domain of f. So I'm seeing which ranges of g have a domain of f. So 3 pairs with 2 in my f, and 2 pairs with 4 in my f. And that's my range of f. And my final answer is going to be my first set with my second set. So 6, 2, and 4, 4 would be that composition. All right, 2 more things. We also talked about shapes of our functions, okay? So this is where we talked about even, odd, positive, negative, all that kind of stuff. So remember, our degree is the highest exponent. So my degree is 2. I'll also ask if that's even or odd. 2 is an even number. The amount of turns the graph can take is my degree minus 1. So I'm going to say 2 minus 1 is 1. So that's my number of turns the graph can take. Then there's the shape of the function. So remember, even functions point in the same direction. So be either both up or both down. Odd functions point in different directions. The way that they point depends on the coefficient, the leading coefficient. So this first number, if it's positive, even, it points up. If it's positive odd, we got to look at our second arrow. So if my second arrow points up, it's positive odd. Even down is negative. And on my odds, if my second arrow is pointing down, it's negative. So this function here is an even positive, so it would both point up. We can graph these on our calculator. So I'd go to y equals and I would type in my function. All right. And then I might ask you to go to your table and tell me, like at x equals 4, what the y value is. The last thing is the amount of zeros a graph has. So the amount of zeros is how many times it crosses the x-axis. So this one touches at 0, which means that 0's a 0. But if it crossed right here and right here, that would mean it has 2 zeros. If it only crosses once, it'll be 1 0. If it crosses 15 times, it has 15 zeros. And lastly, the last thing we worked on were inverses. So remember, if two functions are inverses, then if I take the inverse of the first, it should equal the second. So if I ask you to find the inverse, this is what we've been doing, so this is fresh on your brain. First thing I do is switch my x and my y. So remember that f of x is code for y. So I'm going to make my y x, and I'm going to make my x y. So I switch, and then I solve for y. So remember, get rid of the outer branches before you get rid of the whole tree. So 3 is hanging off the end, so I need to subtract 3 from both sides. And then I divide everything by 2. So this is the inverse of 2x plus 3. Alright, so you're going to be doing a set of review problems, 15 questions. It'll be due tomorrow when I get back. It is your homework. So if you need to watch parts of this video again, go ahead. Miss Erickson has the answer key, but she is not going to let you check your answers until you show that you've done work and that you have an answer. If you do not show your work, I will not give you credit. Alright, I will see you guys tomorrow.